Alright, so we're going to go through section 7.4. This is video 7.4c. 7.4, chapter 7 is rational expressions. 7.4 is rational expressions, adding or subtracting rational expressions. This is video C. We're going to talk about adding and subtracting rational expressions with different denominators, and this is a second example. 7.4b talked about the first example with a different denominator. Now we're going to talk about another example using rational expressions with different denominators. So we're going to fast forward, hopefully, through everything that we've seen here. So right here is where kind of our steps are that we talk about. All these in blue basically talk about converting the fraction from different denominators to common denominators. We've got to factor each denominator. We've got to find out what the lowest common denominator is. Lowest common denominator includes every single factor from every single denominator raised to the highest power. And then step 3 is what's missing from each denominator, and step 4 is multiplying the numerator and denominator of each fraction by what's missing in its denominator. And if you need to print this out, go ahead and print it out. It's on D2L as well. After we convert each fraction into a fraction with a common denominator, then 5, 6, and 7 are pretty straightforward. You add or subtract the numerators as you need. Step 6 says the lowest common denominator just stays the same. In other words, 1/3 plus 1/3 is 2/3, or 1 plus 1/3. The lowest common denominator stays the same. And then simplify if you can, or if you need to. So let's go through. We did this one already in 7.4b. We're going to do this one now in 7.4c. So we're going to take a look at these. And the instructions say add. And if it didn't say add, you'd have to take a look at this and say, well, there's a plus sign between them. I'm not multiplying, I'm adding. So what do we have to do? We've got to convert each of these fractions. We'll call this one the blue fraction. We've got to convert the blue fraction and the green fraction into a common denominator, or into fractions with a common denominator. So what do we have to do? We've got to convert each of these to a common denominator. What do we have to do then? Well, we have to find what that lowest common denominator is. Lowest common denominator includes every single factor from every single denominator raised to the highest power. So over here in the blue fraction, I'm going to say that this is x minus 5, and we've got to say that x minus 5 is a factor because we can say that it's 1 times x minus 5. And remember, factors multiply together. X is not a factor, 5 is not a factor, but x minus 5 is a factor. So we've got to also factor the green. We've got to say, well, x squared minus 25, let's see, x squared minus 25. If we factor that, we've got to say that, well, there's a difference here between a square, a perfect square, and a perfect square. 25 is a perfect square, it's 5 squared. X squared is a perfect square because 2 is even. So this denominator factors into x minus 5 times x plus 5 because it's a special polynomial. It's called a difference of squares. That's something that's really kind of really a nice, more than a nice to know, probably need to know. So this x squared minus 25 factors into x minus 5 times x plus 5. This blue denominator is x minus 5, so our lowest common denominator includes every single factor from every single denominator raised to the highest power. I start with my blue factor. X minus 5 has to be over here. Then you go to the green denominator. What factors are there? X minus 5, well, that's there already. My lowest common denominator also has to have the x plus 5. So I've got x minus 5, x plus 5 as my lowest common denominator, and then you raise each one to the highest power that you see it in any denominator. This is to the first power, this is to the first power, this is to the first power, so each of these are to the first power. Our lowest common denominator is x minus 5 times x plus 5, and there's our lowest common denominator. So we need to rewrite each of these, the blue fraction, or the blue rational expression, into something that's equivalent into into something over x minus 5, x plus 5, because this is going to be our target lowest common denominator. And the green fraction also has to be written as something over x minus 5, x plus 5. So that's going to be our lowest common denominator. That's our target for converting this blue fraction into something over x minus 5 times x plus 5. So I'm going to rewrite my blue fraction here. I'm going to say it's 1 over x minus 5. And I've got to say, well, what's missing in my original denominator that's not in my original denominator, that is in my target lowest common denominator? I've got an x minus 5 already. There's an x minus 5 here, so I've got there's an x minus 5, or sorry, x plus 5 is missing. So I've got to multiply by x plus 5 over x plus 5. And essentially we're multiplying by 1 here. In the red, we're multiplying by 1 because x plus 5 divided by x plus 5 is 1. So when we multiply a blue fraction by this red fraction, we're multiplying by 1. And all we're doing is just kind of converting it to our lowest common denominator. My denominator becomes x minus 5 times x plus 5, x minus 5 times x plus 5. My numerator is 1 times x plus 5. So my numerator becomes x plus 5. So now we've converted our blue fraction, our original blue fraction, into the blue and red fraction. And if you look at this, and if I gave you the blue and red fraction, I said simplify, you could say, well, x plus 5 divided by x plus 5 is 1. So we'd have 1 over x minus 5, which is what we were given in the blue fraction already. So now we're going to convert the green fraction and do the same thing, essentially. We're going to write the green fraction, negative 10 over, I'm going to write it as its factored form, or in its factored form. Negative 10 over x minus 5, x plus 5. And we say what's missing in my green fraction, in my denominator of my green fraction, that's in my target fraction, or in the target lowest common denominator. Well, my green denominator is the same as my red denominator, my red target denominator, so we don't have to really change anything. So we leave the fraction as it is, and we say, well, it's now negative 10 over x minus 5, x plus 5, because the original fraction had everything in the lowest common denominator, so we don't have to modify it. So that green fraction that we were given is the same as what we need, so we just leave it the same. And now we say, well, now I've got to take my plus sign and go down here and put my plus sign between them, and now say, what is, now can I add them up? I've got, up here in my original fraction, I couldn't add them up because I didn't have common denominators. Down here in my multicolored green and red, and blue and red and green and red fractions, I do have common denominators, so now I can just add them up. What I do is I add up my numerator, x plus 5 plus negative 10, and the denominator stays the same, over x minus 5 times x plus 5. And now I'm going to play devil's advocate and say, now, can I cancel that x plus 5 with this x plus 5? The answer is no, because remember what we can cancel? We can cancel factors. So factors are multiplied together. So down here in my denominator, x minus 5 is a factor because it's multiplied by x plus 5. X plus 5 is a factor, it's multiplied by x minus 5. But up here, x plus 5 is added to negative 10. So this is not a factor. X is not a factor, 5 is not a factor, x plus 5 is not a factor. The entire numerator is a factor. So we can say, let's maybe see if we can cancel things out if we simplify things. So now we've got to, because x plus 5 did not cancel with that x plus 5, we have to simplify our numerator. So we say x plus 5 plus a negative 10 is the same as x plus 5 minus 10, and that would be x minus 5 simplified, my numerator. My denominator is x minus 5 times x plus 5, and that hasn't changed. And now we can say, all right, well, now does anything cancel? I can say that that is x minus 5 times 1. And now x minus 5 is a factor. X is not a factor. 5 is not a factor, but x minus 5 is a factor because it's multiplied by 1. So now the x minus 5 cancels with, oops, sorry, I got to close that. X minus 5 cancels with x minus 5, because x minus 5 divided by x minus 5 is 1. And my answer then is 1 in my numerator over x plus 5 in my denominator, and there's my answer. All right, hopefully you got that one all right. You kind of worked ahead of me and got to the same answer that I got. All right, I'm going to leave this one for us to work on. I guess not us to work on, but you to work on. So let's take a look at this one, just kind of as an overview, because we're getting on in time. But let's see. What we're looking to do is, if we're subtracting, because this really doesn't have any directions at all, so we'd have to take a look at it and say, all right, well, if I have to work on this one, I'm saying, well, here's a subtraction, here's a subtraction. So if we're going to add or subtract, these are both subtractions, but if we're going to add or subtract, what we need to do is have common denominators. P minus 1 is different from P plus 6, it's different from all that. So what we need to do is, number one, convert all these, convert this fraction and this fraction and this fraction to a common denominator. Let's see, if we're going to do that, we've got to find the lowest common denominator. So if we're going to find the lowest common denominator, we've got to factor this and see what that factors into. Again, I guess because a is 1, we're going back to chapter 6, if a is 1, then I'm going to say use the trial and error method to kind of factor out what that is. My guess is it'll be probably these two factors combined or multiplied together will give you that denominator. That's my guess, and I'm sure that's going to be correct. But then we find what our lowest common denominator is, and then we find what we need to multiply each fraction by to convert it into something with the same common denominator. Use this as your reference, and then convert each fraction, and then pay attention to the fact that we have subtraction and we have subtraction. So make sure you're subtracting everything that's right here, and you're subtracting everything that's up here in our converted fraction. And then you get to an answer. So bring that answer into class, and we will discuss that in class, and that'll be your ticket to get into class.